Hello and welcome everybody to the Builders Track. My name is Tatiana Bellendier and I'm a Principal Security Architect at Daimler Truck, and today I will be moderating this session. In the next 45 minutes, Matt will talk us through the landmines in the API landscape. At the end of the session, we have 10 to 15 minutes to address your questions. Please put these questions in the text form in the window close to on the right of the Hoover streaming panel. We'll be watching that and addressing this. And please note that the chat function in Zoom is blocked for attendees, so use the Hoover app chat and Q&A pane for addressing questions. And with that said, welcome, Matt, and let's enjoy your talk.
Yes, thank you very much. Let me get my screen shared. We'll get rolling. Assuming you're seeing my screen, we should be all good. So, as Tatiana said, welcome to Landmines in the API landscape. Let's get started. This is going to be a bit of a fire hose. I've got lots of material for you. So quickly, just going through what we're going to talk about. I'll do a quick intro, a little bit of background and whatnot. I'll go into why attack APIs and what makes them interesting and why they're, well, I mean, I guess it was Gartner was saying that they're going to be the #1 attack vector in this year, which is probably going to be true. And then I'll talk about finding landmines, where the problems are. And I'm going to take this from the perspective of both an attacker, what an attacker would do, as well as a defender, and what the defender sees when those types of attacks happen. And then I have a conclusion, a couple of key takeaways, etc. So who am I? I'm Matt Tesauro. I call myself a reformed programmer and an AppSec engineer. My first job out of college was writing PHP 3, which tells you how long ago that was. I currently work as a distinguished engineer for No Name Labs. I've got 14-ish years with the OWASP community. I'm a core maintainer of Defect Dojo. I'm a co-lead of the AppSec pipeline. Oh, I'm also doing the podcast now, so I should put that in there too. And OSWT is kind of dead, so I should probably take that off. I'll replace that with the podcast for my next deck. I've got 22-ish years of using free, Libre, and open source in Linux. I'm currently, when I write code, I write it in Go, and that's a picture of me doing a dual front kick board break to get my 2nd degree black belt. And I also am a founder of 10 Security. So why attack APIs? Well, APIs are simple, right? It's just, you read the Wikipedia definition. An application programming interface is a connection between computers or between computer programs, right? So your program written in, say, Ruby makes a REST call, say, to my program written in Go, and I send you back some stuff over HTTP, straightforward, super simple, no biggie. Well, actually, it's much more complicated than that. When you get down to it and you actually have this set up kind of for real, these end up being very complicated. If you have, say, a web application here, backed by a bunch of APIs, you'll usually have an API gateway in between that web app and the APIs. You'll have a web application firewall in place. You might have a mobile app that talks directly to the API gateway. Those first level of APIs may end up calling back to other APIs that are within your DC, or maybe off in some other cloud, or it could even be a third-party provider that you're getting services from. So these things get really tangled really quick when you do them at scale. So let's say you do have an AppSec program in place and it's pretty solid and you're pretty happy with it. If you look at the circle on the left, that's kind of the general AppSec tooling you would have, right? You might have a WAF and SAST and DAST and SCA, threat modeling, developer training, some kind of anti-bot in place. Hopefully you have an app inventory. Right, if you have all those things in place and you add API security tooling, or well, if you consider the API security tooling you need, there is some overlap. Like SAST works the same for an API and a normal application. Threat modeling, same. Maybe different questions, but generally the same. SCA can work for both. DAST maybe works for both if you have a decent DAST tool, although DAST tools generally don't do all that great with the traditional DAST tools, don't do all that great with APIs. But then you have all these other things that are very API specific that are probably not in your tool belt in a traditional or a normal or a, whatever AppSec program that hasn't seen APIs before. So there's a lot of gap, and this large gap is, I think, where a lot of the issues come from. So you may have a great AppSec set of controls, but API security issues won't get caught by all of them. And it's all about the data. Like if you think about what was it, Clive Humby? I don't know how to say that poor British man's name, but he coined the term, the data is the new oil, right? And if you're moving the new data around, you're going to move it around in pipelines. And in tech, those pipelines are APIs. That's how you move data around. And so now you have the value of a lot of businesses being the data they hold and how they move that data around being APIs. And then the flip side of the coin is, as over the years, we've had browsers that have got continually and incrementally gotten better and better, and the controls we have in place, be they a ton of different security headers now you can use for web applications, as well as MFA and CAPTCHAs and tons and tons of browser hardening mechanisms that we now have at play. Those don't exist for APIs, and APIs haven't had the years and years of sort of field deployment at scale that browsers have had. And so in a lot of cases, you'll see that if the same functionality exists in a website or an API, as an attacker, the API represents something with far less controls or security guardrails around it. So why wouldn't I attack that API? And then just quick talk about different types of testing, because I'll explain why I need that in a minute. Right, you can have black box where an attacker has zero knowledge. It's, quite literally, I'm sitting down with a laptop in a coffee shop somewhere and just poking at IPs. Gray box where you may have limited information on the target. The use is usually for like a penetration test where you'll have maybe an IP range, so at least you know where to focus your attacks, but they don't give you much more than that. White box where you have full knowledge, and a lot of times some of the controls, like say a web application firewall or some kind of intervening device, will be turned off. And then crystal box where you have full knowledge, including source code. Right, so these are different levels of attack. And the reason I talk about these, when I get into the landmines, I'm going to talk about them from the perspective of black box, because that's the least knowledge you can have. Hopefully, if you're working at a place, you'll be much more white or crystal box. But I wanted to give you kind of the more full overview of what's there. And then you cannot forget my favorite, pro bono pen testing, otherwise known as somebody hacking you, right? This is what happens when you put an answering port on the internet, somebody starts poking at you. So this is always in the background, free with any internet connection, is somebody poking at your resources. And then finally, when I talk about API security, I think there's three major areas or pillars or categories, whatever you want to say, that are worth talking about. One is API security posture, and this is just understanding the inventory and all of the APIs that you have, all the endpoints, as well as who's calling that API. Where is that call originating from? Is this an internal, API to API call, or is this coming from public internet? And then probably most importantly too, what data is sent and received, right? Am I sending out PII or some other kind of personal or GDPR type data? Is it just public data? What is it, right? How sensitive is that data? And so if you have that inventory and a categorization of how sensitive the data is, you have a very good sort of map of your APIs, and you can make some good decisions in terms of how much effort is worth putting behind securing those different APIs. And then API runtime security. So this is watching the traffic that goes to and from your APIs through some mechanism, and getting an idea of what normal traffic is, and then obviously doing anomaly detection to find out what is abnormal traffic, and doing alerting or detection or whatever it takes to sort of let the security team know, hey, there's something wonky going on with this API. And then API security testing. So this is just to get an assessment of the security state of your API. Now, since API, the source code that makes up API and the source code that makes up applications are going to be tested the same for SAST. I don't generally include SAST in API security testing because that really is just a normal part of what I would consider AppSec. So really, this is generally speaking DAST testing of APIs. And then you need to take those results that you get and feed them into whatever makes sense for your business. That's usually something like a Jira backlog or whoever your developers track issues with the software and hopefully get them fixed. So it's posture, runtime, and testing. And then finally, I think one thing from a security perspective, you need to have a slightly different definition of an API. I think the term API has almost become like the term website. It's so broad that it kind of means nothing. So I am very specific when I say API. And what I mean by an API, particularly in regards to security controls, is three different things. You have a host name, right? What DNS name is that API running on, right? You know, I don't know, uat.bigcorp.com. You have a path, right? /API/v3/users, or API v1/cart show items, whatever the path is. And then you have an HTTP method, right? Post, put, get, patch, delete, etc. And why you need all three of those is to make a good security decision, you have to have all three, because you can have only one of those vary, and very radically different security postures can exist. For example, doing a GET request to v2 users all, in other words, getting a list of all the users, is very different than a delete request to all users, right? It may be bad for an attacker, let's say, to get a list of all users, but it's even worse if they can delete all your users. So here's an example where only the HTTP method changed, but the security ramifications and controls we need, et cetera, around it are radically different. And then in that second example, we're posting to uat.example.com user admin. Here I'm adding an admin user to a UAT environment. Maybe kind of interesting, not super scary. In the second example, we are posting to production and adding an admin. Well, adding an admin in production is a very interesting from a security perspective, something happening. So this is another case where it's just a single method name changed. Everything else is the same, but the security ramifications are radically different. Okay, let's go find us some landmines. So I'm going to start in a traditional sort of pen testing perspective. Let's do some recon. Let's find APIs to attack from a black box perspective. So the first thing you'd want to do is just do passive recon, right? Just gather all the information you can about your potential targets. And even if you are internal, I think doing this exercise either at your desk or maybe from a coffee shop, if you want the true external perspective and a nice coffee, isn't such a bad thing. But in a passive recon, you're going to have no direct interaction with the target. This is just to see what is out on the public internet, so to speak, for your APIs. What can I find out? Now, this may be a lot if your API is a public API that's meant to be used, such as like the GitHub API. That's very public. They don't hide the documentation for that, et cetera, right? That's by design. If it is an internal, though, API, you probably don't want to find much of anything about it. So this is where you just want to know what the world sort of knows about your API. You can do things like Google Docs. The OWASP mass tool is fantastic for DNS enumeration. You might look at things like Shodan. Programmable Web and APIs.guru are two great sites to find lists of publicly known APIs, which are yours or may not be listed, depending on the background. If it is a public or open source thing, this is where GitHub issues and PRs can be very interesting to find potential security issues. And then if it is a public API, there may be Stack Overflow posts or something like that, where someone's trying to get help with a particular API call. From the defender side, you really can't do much. It's public info. Now, you can do things like I've seen vendors put the API docs behind a customer login page, right? And that may make sense depending on the use case of your API, and that certainly can sort of make it harder to find out about your APIs. So So you may not want to advertise them at all, but you may also want to advertise them because you make money by people using your APIs. Like if you're Stripe, you want your APIs to be as easy to use as possible. So you will have a getting started page. You will have public documentation. So this may or may not be something that you can actively do something about. But in the case of the tooling, posture, runtime testing, they're not really in play here because we're not even sending any kind of traffic to your API. So, and you can't really test your API to see if the docs are public. So this is more just of a human exercise. And so you've done your passive recon, now it's time to go active. And this is where you gather public information, all that you can from your targets by, and also playing nice, right? As opposed to not sending any traffic. Now you're sending traffic, but you're not trying to be malicious yet. You're just sort of getting a feel for things. So the idea here is to do basic recon, do things like you can look at the robots.txt, particularly if you're completely blindly looking at this. If you're looking at a API-backed website, this is where the dev tools, the network tab, and all those different tabs that you have in your browser dev tools will give you great hints at what's out there. Obviously, local proxies like Zap or Burp are fantastic for this, either for API-backed mobile apps or websites. You can do things like brute forcing URLs with something like Dirbuster, Derby, GoBuster. They're all the sort of popular directory brute forcing tools. And Kite Runner is an API focused brute forcer that's very useful, and maybe even an Nmap scan, but at best for the defender, it's pretty hard to see this traffic as attack traffic, right? If I run an Nmap against your IP range, you can probably see that, but honestly, if you have an open IP to the internet, everybody's, and not everybody, but you're getting enough Nmap that I'll just get lost in the shuffle. If you have a single page web app or API-backed mobile app, you can't do anything about dev tools. They're built into everybody's browser. You just have to deal with that. I have seen interesting things with robots.txt before, where one particular client I was interacting with had their CPU-intensive pages listed in robots.txt because when they got crawled, it was actually spiking CPU usage on their website. And my position to them was, you probably need a better way to handle this, because as an attacker, that robots.txt is almost like a guide to doing a DOS of your web application. And then for the three types of tools, posture, in this case, really just helps you focus your limited resources where it needs to be the most risky of your apps. Runtime can discover active recon if it's noisy enough. Certainly something like Dirbuster or Kite Runner will be rather obvious, particularly if I'm trying to, if you have a non-public API and I'm trying to brute force URIs for that API, those will stand out pretty blatantly. And then testing, this is recon. There's not too much you can do about testing from a recon from a testing perspective. So we're done with recon. Let's move on to discovery. So I've got targets. How do I use them legitimately? Right. So this is where, particularly if you're first seeing an API and testing it, you need to just understand how to legitimately use that thing. How do I make legitimate calls? How do I authenticate? How do I do whatever the use for that API is, right? If it's Stripe, how do I make a transaction? If it is something like Stripe that's very public, there will be API documentation, getting started guides, blog posts, the whole nine about it. If not, it may be kind of interesting. If it's an API that is not publicly known, this can be really challenging to figure out how those things work. You might be able to find a Swagger file. A lot of times there's a URL URL that'll have the Swagger file posted for you, or RAML, WSDL, Waddle, all those different ways to specify specs for the API. I have had cases where the provider of the API also provides something like a command line client. Even though their APIs may not be publicly known, if you put something like Burp or Zap as an upstream proxy to that client, suddenly you can see exactly how those API requests work. I've also had ones where the documentation was so terrible that I had to use a client just to find out how to talk to the API. And then once you get those, particularly when you're doing a blind attack where you don't have the list of API endpoints, you can start to manually create a list of those either by brute forcing, finding them in the dev tools, etc. But you do want to start to enumerate a list of all of the API calls that are available to you. And then on the flip side, as an attacker, most of the traffic just looks like some, excuse me, newbie, right? Trying to learn to use your API. They're going to make some bad auth calls, but it's going to be a onesie, twosie kind of call. Maybe there might be some curl requests or something, but it won't look too weird and it won't be all that pronounced. Now, if you do have an API-backed mobile app or a single-page app or web application, right? So these may stand out, right? If you're only expecting API calls from your mobile clients, like say Android or iOS, and suddenly curl starts calling your API, that's a little weird, right? That shouldn't happen. And that can stand out from a defender point of view. And if you have an undocumented, non-public kind of API, you're going to see a lot of failed requests as the attacker is trying to understand like exactly what your API looks like. So there's a couple cases where these discovery attacks, for lack of a better word, or the discovery activity will show up and look pretty obvious. So from a posture perspective, obviously you can use that to focus your resources, but it's also good to be able to know like this is an internal only API. I should never see a public IP hit this thing. And if that happens, you got some kind of network issue that's pretty hairy that you need to jump on quickly. Or if you have an API gateway in place, you should only have requests originating from the API gateway. And if suddenly they don't, then somehow someone is able to bypass your API gateway. Runtime, you can certainly discover some of this traffic if it is things, like I said, where you expect a very specific client only to be talking to your API and you get some oddball requests like curl or the request library from Python or something. Or if you have undocumented APIs, you'll probably see a lot of failures. So runtime can definitely help you here. And testing, it's proactive. It also doesn't really help you much for discovery. Hopefully you just won't have issues to begin with, but they're still going to be discoverable. Oh, and if you are doing this from a testing perspective, and particularly as a blind test or a non-public test, discovery can seem easy, but you can spend loads of time trying to find, there's got to be another API endpoint here. There's got to be. So be warned if you're doing the testing side of this, don't let this be a time sink. Okay, let's go on to the active side of things. Like, let's get malicious now. So as a black box tester, I found some APIs. I've understood how to talk to them legitimately, and I have a fairly good idea of what's out there. Now it's time to see if there's some vulnerabilities. And just to give some structure to this and not just sort of randomly talk about things, I grabbed the OWASP API top 10, and I'm going to walk through all of those and explain the attacker and defender side of those two pieces. So the first one, broken object level authorization. In this example, right, we have Benjamin here making a request to an API with a token, a bearer token, as well as his user ID, and he gets back Benjamin's information. Now there is some PII in there, but hopefully Benjamin knows his own date of birth and his phone number and his SSN. But this is actually a valid request. This is how it should look, right? This is a good request. However, if Benjamin gets a little nefarious with us and he keeps his same token and he keeps the same name, but he changes the user ID to a different numeric value, he now gets Charlotte's information and her DOB and her phone number and SSN. And this is, of course, a bad request. From a defender point of view, great request if you're an attacker. But this is BOLA. This is what BOLA looks like. So from an attacker's perspective, how do I find BOLA? You can look at how resources are structured and try to find any kind of IDs or unique values within API calls. These can be numbers like like we saw in the previous example, are these maybe non-numeric, right? These can be simple, like strings, right? They don't have to be numbers. Generally, they're numbers, but they don't have to be. And then you make calls to those resources with your same existing token, however you're authenticating, and you just modify those numbers and see what happens. It's really not too hard. You can also do things if you have 2 user accounts, create something as user 1, and then as user 2, try to request that something. And this depends on the use case of the API. If the API has resources isolated to users, then this would be an example of a BOLA attack. If everything's public, obviously this is not a BOLA attack. And then as you're doing these, look for response differences, kind of like fuzzing, honestly. If there's a different response code, 404 means it doesn't exist. Generally speaking, if APIs are well coded, 405 means you're unauthorized. So that tells you, 405 does tell you, hey, there's a resource there, I'm just not gonna let you see it. Time to response can sometimes give you some clues about existing or interesting IDs, and length of response very, very seldomly happens, but sometimes it can. From a defender, unfortunately, detection takes a fairly deep inspection of those API calls. Right? In the example I showed a minute ago, it was only that one ID string that changed. Otherwise, the request was the same in the good and the bad requests. So from a looking at the HTTP, even the payload perspective, a lot of WAFs are probably going to fall short here because it looks like a normal, well-structured bit of JSON. It doesn't look weird. Just one of the data values inside of there doesn't match what it was expected for your token, right? Your bearer token in that case. So this is really kind of tricky for sort of more web app focused intervening devices like WAFs to find. So you really need a deeper inspection to be able to understand that this bearer token is generally associated with this user, not this other user. So this is where you kind of need a specialized tool, or API specific tool, I should say, for this. If I'm an attacker and I'm looking for BOLA, you're going to see a lot of failed requests or authorization issues. So this is a great way to sort of to find those attackers before they get to do anything interesting with your APIs. If you see 2 similar requests with different ID values in them from the same client in a short period of time, that is a huge clue. And this is something where if you have decent anomaly detection with AI or ML or whatever you want to call it, they can point that out, right? That's something that a computer can find very well for you. Posture here really tells you the areas that have that most risk for BOLA. Runtime can detect BOLA, and if you have a decent bit of testing, it can find that BOLA hopefully very early in the production, in pre-prod, whatever you call your early, not quite to production yet. That's where you'd like to find these things. Broken user authentication. This is where you have the ability to log in, basically username and password into an API to generally get a token back that you then use to do the rest of your requests. As an attacker, I can brute force credentials. I can do password spraying. APIs don't have the nice things that browser has, like MFA or CAPTCHA. This can also be the places where there's no anti-automation on password resets, particularly on API-backed web apps. You can do the whole thing of playing around with base64, and sometimes they'll base64 things and thinks it helps. It doesn't really. Or there can be issues with the tokens themselves. Either they generally have low entropy, or there may be some JWT, a JOT specific weaknesses, like the none algorithm attack. If you don't know that, do a little bit of reading. That's an amazingly hilarious thing. You can have weak passwords for JWTs. You might be able to crack them. There's this nice tool called JWT Tool that'll do some of that for you. But generally speaking, this is an attacker trying to get authentication bypass so they can get a valid token to then make requests as that user. And if they are brute forcing credentials or doing password spraying, this is going to be very noisy. So for a defender, it's not hard to see. Password spraying is noisy. If crypto is used incorrectly, you can usually find that more statically than dynamically, honestly, although decent API runtime tools will see that and tell you that you have weak secrets. There's a great RFC, the JWT Best Practices RFC. If you are using JOTS, I would recommend looking at that. And then some companies have actually removed authn from the API altogether because they get so much better protection from a traditional web app. They make the human log into a web app, get a token, and then add that to whatever their API automation is. GitHub does that actually now currently, which is pretty interesting and didn't before. Posture, this is where you can identify any kind of authn that exists in your API. So it's very useful to sort of focus on removing this problem from your plate. Obviously, brute forcing, password spraying, those things are noisy. Manipulating JWTs is noisy. If you have deep inspection, those are things that runtime can help you with. And testing can identify those poor practices with authentication before you push stuff out to prod. Excessive data exposure. This is where you have APIs that are too verbose in their responses. This is generally caused by a developer using a 2JSON method, right? That takes a data structure, JSONifies it, and then they just add it as the response to an API call. Generally, that'll be the full data model, and it won't be just a subset. And in that case, they rely on the clients to sort of filter or just ignore the extra data that they send. And if you're only using your client, say your mobile app, that's great in theory, because the mobile app will ignore that. But as an attacker, I don't have to use the mobile app. I just have to use something that talks HTTP, and I won't ignore that extra data, particularly if it's interesting. So from an attacker's perspective, you want to look at things that generally will have a lot of data around them. This is like a profile page or an inventory page, or if there's some kind of linked, like, friends kind of users. You can make guesses to where there might be internal metadata where this is a different, like a role may be implicit, but not shown in a profile. You might be able to get that role out as excessive data exposure. And this can be very time consuming if you're looking at a big API. There was a health care API I looked at that had like 435 methods, or endpoints, I should say. And then you add the HTTP methods on top of that. They had lots to do there. So this can also kind of be a bit of a time sink. Now, from a defender, unfortunately, if you have excessive data exposure, my request is just a legit request. You're just sending back more data than you should. So this will look like normal traffic. And this is a place where SAST or static analysis can help you find, or like SEMGREP can help you find those 2JSONs or whatever it is for your language, right? Where you're having developers directly dump a data model out to the response. And this is where you need to find out if your clients are relying on filtering of data, because that's a warning sign, if nothing else. And in the better designs, you actually have separate data objects for internal storage versus what goes out over the API. So maybe you have 15 elements in the internal representation of that data, but the API only gets 6 of those. And you have 2 different data objects in the language, whatever programming language you're using, so that I have to consciously, as a developer, add a new data item to that API only data object. And then I can safely use those 2 JSON things, because I've done that segregation of data explicitly when creating the API data object. Posture can show you where sensitive data is, to know that those are the sort of spooky parts. Potentially shows you large data responses. Runtime can show you large responses, but you may have those on purpose, so that may or may not be useful to you. But it can definitely detect what happens with data exposure from an attacker perspective is I'll find it for one user and I'll try to get it for the rest of them. Lots of telecoms have had this problem where they had a problematic API, and I figure out if I'm going to call it once, I can get one person's information, but if I call it 10,000 times, or God help you, 1,000,000 times, I can get 1,000,000 people's information. So where this will generally show up for runtime is I might be able to get the first request out and steal that data, but as I try to steal data in mass, it's really going to show up for runtime. So runtime can definitely help you here. And then testing can find those verbose responses early in your pre-prod cycle. Lack of resource and rate limiting. This is where you don't because APIs are meant to respond quickly to multiple requests, you kind of need to rate limit them so they don't fall over. Also, so that you can, if you're having an API that's used, like say Stripe, by multiple clients, you don't want one client to sort of eat up all of your resources. So as an attacker, this can be fun. If you have a method, an API call that lets you add items of some sort, like, I don't know, my favorite songs, add several million songs and then ask for your list of songs. And if they don't have pagination, this is a great way to have a sort of an application level DOS. So sort of lack of pagination is a giant clue. This is getting much better, but in the early days, I found lots of those. The fuzzing and brute force can find some of these. This is where you're just going to do interesting things like play around with the headers, or you do different IP requests, or just anything to try to get around the rate limiting. You can play null terminator, case switching games, anything to sort of confuse an intervening device that's rate limiting you, if that's an API gateway, a WAF, or some other network device. And I have found cases where they did have rate limiting, but it was set so high that I could already start to impact their performance before the rate limiting kicked in. So as an attacker, even if you find it, that may not necessarily mean the API is safe. From a depender perspective, most of these requests are going to look normal. They might have larger responses. I've done sort of stupid API tricks by, there was one XML API where I injected 32 meg of space in between two XML elements and sent it to the API, and it fell over. So that would obviously show up very easily in runtime. Also, runtime can see a lot of unusual headers or weird encoders or null terminators that you don't expect. So a lot of the techniques you do to try to get around rate limiting end up not looking like normal requests, and therefore can be spotted with runtime protections. And if you have observability, decent monitoring, you can see usage spikes. A lot of, as I'm testing this, I'm going to be poking things that are CPU or RAM intensive, and this will show up. So as a defender, you can see these odd spikes, and if you're quick enough, nimble enough, you can actually take action against them. So posture will help you understand what things need limits and where it makes sense to put in limits. A runtime can definitely see the oddball traffic that is trying to bypass or get around any kind of limiting device. And then fuzzing can sometimes find data issues, these rate limiting and resource issues early, particularly for app level DOSes. Broken function level authorization. This is where you have multiple groups or roles for an API, and I can make a legitimately tokened request for one role to another role's method, and it's allowed. That's broken function level authorization. So as an attacker, I want to find APIs that have multiple roles or groups. Sometimes I think this is poor design, but you will find that backplane or admin functions are also exposed in the same API that sort of normal user functions are exposed at. So those are great places from an attacker. And then I've also seen instances where the documentation will not list kind of dangerous or state changing methods like delete, put, post, patch. But the API will actually accept those requests. So if you're reading the docs and only doing the legit thing, you don't try them. But there's nothing to say you can't throw a delete to a resource, even if it's not in the docs, and see what happens. And to find this out, usually create items within one role and try to access those from a separate role. And this is very context dependent on the API you're testing. You can use brute force and some other techniques to try to find those backplane or admin type operations. And you can play around with headers, request data, et cetera, to try to originate as a trusted IP, usually by header manipulation, like X forwarded for, et cetera, to maybe get access to those admin functions. So from a defender, this is obviously critical for things that have two or more roles. If you have a single class of user across your API, then you sort of can't have this problem. And you will see lots of errors when I'm trying to discover these issues, because I'll send a post request to something that doesn't support post, and you'll get an error, right? So that can be very useful. You can also see the same client do multiple roles within a small period of time. This is another great place where ML or AI kind of automation from runtime can help you find attacks. Failures, if you get failures or requests, either failures to the backplane or failures to requests that look like backplane paths, that's another great sign that somebody is being naughty with your API. And then if you see funny request headers or bodies where someone's playing around to try to bypass or to try to get around the function level authorization, that's another great sign. So posture can definitely help you determine APIs with groups or different privilege levels, so you know where to focus your efforts to try to get rid of this particular category of problem. The unusual and failing requests can easily be seen by runtime, or changes in a role with a single client within a short period of time is atypical traffic, generally speaking, for most APIs. So that's very detectable. And then obviously testing, you can run this kind of testing early in pre-prod to find those issues and hopefully not let them go out to prod. So mass assignment, this is where I'm sending a data payload into an API, and I'm adding additional data in there. And if I have the opposite of the to JSON, but I read in JSON and I turn it into a data model, automatically, I can then change data values that aren't supposed to be exposed by your API. And so from an attacker's perspective, look at areas where it feels like there should be more data. This is almost the flip side of our previous issue. And you can find issues where there's differences in responses or requests for different privilege users, right? If you notice as an admin user, I have an admin equals true and somewhere in your JSON, we'll add that to a normal user and see what happens, right? A post to that normal user. This is where you can guess and brute force values. A lot of APIs will simply ignore additional data and just dev null it. So there's nothing to say you can't add 10 possible admin-ish fields to a request and just see what happens. And maybe you get lucky on one out of those 12 you added, right? It can't hurt. Sometimes you'll get error messages and other helpful information when you're trying to sort these out from the APIs. So thank you, API developers. Fuzzing can sometimes find these. And if you do have broken function level authorization, this can get really interesting, because then I can change email or some others, like particularly like a password reset email or something sensitive about another user from my existing user's account. And this might allow me to say compromise one account and then go and compromise multiple others. So this can be very powerful if it's combined with that broken function level authorization. So if you have deep inspection of your API traffic, you can see these additional fields, right? Because I know that this API request on every other normal user has 10 fields and suddenly there's 27. That's very easy for runtime to find that and alert you to that anomaly. You'll see a large number of failed or invalid requests depending on how your API will handle that additional data added. The API sizes will increase. You'll see APIs with different roles. You need to watch this more particularly for APIs that have different severities. This can increase the severity if you have different roles or privileges. Let me put it that way. In other words, if you're subject to broken function level authorization, or you have that multiple role in the API that you're looking at, that makes this even more of a problem if it exists. And then posture can focus on roles with sensitive data or multiple roles. Runtime can see a lot of this. If you have a larger request, add fields that don't typically exist there, all that's going to show up fairly broadly or easily for runtime. And then testing can show the additional fields very early in discovery, and hopefully get that done in pre-prod. Security misconfiguration, this is just basic stuff. TLS, you have headers with X powered by that leak information about your API. I have default creds if it's like I say, an open source project or something where the default creds are known. You might be able to upload an ICAR file if it takes in files. ICAR is a test virus file. This is where recon and discovery can kind of give you an idea. Verbose error messages are another issue that you can find as an attacker that can kind of help you target other attacks. There may be misconfigured things like Django has a debug mode that is very verbose if there are issues. And if I can trigger an issue and get a ton of information about, say, that Django install. You can find things like intermediate devices like API gateways, et cetera. They usually add headers somewhere. And then you can play games like doing xremote adder to try to call internal functions if they only trust the headers and don't actually look at the true originating IP. And from a defender, this is kind of just, to be blunt, running like Nessus or whatever kind of traditional network scanner can find a lot of these basic mistakes. Also, passive traffic monitoring can find a lot of these things like weird header issues, API gateway bypass. If I have an internal API getting public IPs hitting it, all those things are very easy just by watching the traffic to see. If you have clients that have lots of erroring or malformed requests, that's another sort of indication. Posture can show you weak configurations or API bypass, particularly if you have things like the data classified to where, like I said, this API should only receive internal requests and suddenly I'm getting public IPs. And I kind of put passive traffic monitoring under posture, although it might be done by a runtime piece of tech, depending on what you buy, et cetera. Runtime, unexpected traffic, multiple errors, these things kind of show up fairly easily, malformed responses. And then testing, this is just the basics. You could do fuzzing for API specific things, or hopefully you're running some kind of network scanner to find these issues. Injection, this is traditional injection in any kind of places and tokens, headers, any of the body or the request. Recon can kind of give you an idea where it might be interesting to do injections. There's tons of different great places to find injections. There's loads of fuzzing lists. You can go to the OWASP testing guide, we'll give you a lot of these. There's a bunch of cheat sheets for this. But one interesting thing is second order injections. A lot of APIs will take in really bogus data, and it may not have effect within the API, but it can be used by downstream or internal systems and then pop up somewhere else. And I saw this for real at Rackspace many years ago. We injected into an API a XSS string, and that XSS string went through 7 different systems before it popped up on an internal admin panel. So second order injections really do exist. They're really hard to tell when you're black box testing, but if you are internal, you can find these things out. From a defender point of view, obviously the 101 thing to do is input validation and output encoding. But from a runtime perspective, you're going to see lots of failed or malformed requests, and the traditional fuzzing strings are very well known by both the attacker and the defender if you have a decent runtime. So those will stand out, right? Or 1 = 1 stuck into a request is probably going to be found by even a reasonably good networking device that's watching traffic, right? You also can see a large number of requests that have validation errors to a particular API as I'm trying a fuzzing string, because I'm basically brute forcing a bunch of fuzzing vectors. So those will stand out. And one area where this can be really problematic is if overly trusting east to west or internal API to API calls, where if I can get an injection into one that passes to the second, and it's overly trusting because it's an internal API calling another internal API, even though the data came from outside, you can have some really interesting things happen there. Posture is good to understand which APIs have sensitive data, which would be something I'd want to inject into as an attacker, and then east-west APIs, so it's internal-only APIs. For runtime, you're going to see a surge of errors or weird valid malformed requests or fuzzing strings show up very blatantly if you have even a reasonably good runtime detection. And then obviously you can do those same fuzzing vectors in your pre-prod testing. And if you do that, you can hopefully find those before attackers do. Improper assets management.
Proceed.
Yep.
We have 10 minutes to go, okay?
Ooh, okay, I'm going to go really fast. These last ones are luckily not that hard. Improper asset management means you don't have a handle on what APIs you have out there. And honestly, from an attacker, I can sum up all those bullet points into that bottom line. My pen test was really easy. If APIs are unmanaged and unloved and unwatched, as an attacker, I'm going to have a productive time. As a defender, I need to know all those APIs and to classify them, probably have an API or something else in place, whatever, but you should understand your landscape. Posture, that's what it's designed to solve, this very top 10 issue. So that should do it for you. If you have good runtime, it will update your posture so that as you add APIs, they get added to your inventory. And testing, honestly, not very useful here. Insufficient logging and monitoring is also one as an attacker. You just kind of have to infer that because, gosh, I've been spraying crappy traffic to this API for 3 hours and it hasn't reacted. But it's really hard to tell from external. From internal, you don't see attacks. Like if you don't have logging and monitoring, you may be getting attacked and you have no clue. Unplanned downtime is a resource that you really should have better monitoring and logging. And then diagnosing API issues is difficult. This is just a general idea. I mean, this is more of a SRE kind of thing. But if you can't diagnose API issues, you probably have insufficient logging and monitoring. Posture can tell you how much logging you should have. Obviously, runtime, this is what runtime is supposed to do, monitor. So if you need, if you have a good runtime tool, you can kind of knock this one off your list. And testing can kind of tell you what's logged, but it's not that useful. Whew, look at that, I made it. Bonus material, I'm going to quickly cover this and we should be good on time. Fuzzing, this is covered in the testing guide. I'm going to kind of go quick here because I'm running short on time. But obviously from a defender, fuzzing is very, very loud. And this is where runtime can find it for you. One thing I did want to point out is there's two different ways that I like to think about attacking APIs. You either attack the structure where I have valid data, but I fiddle with how the data is laid out in JSON or XML or whatever the API takes, versus data attacks, which is I have a well-structured data payload, and I just modify the data elements inside of that payload. And I found some really interesting things doing structural attacks where I add 3 of whatever it expects only 1 of, or a dozen of them, or you remove 1, right? So don't forget structural attacks when you're being naughty with APIs. GraphQL, it's pretty much the same for GraphQL, except for GraphQL is a query language. If it allows introspection, I can get tons of, I can pull the whole schema, honestly, for the GraphQL API. But to be honest with you, GraphQL is a huge area. So I'm leaving that as an exercise for you guys. Conclusion, 4 key takeaways. If you know how to test web applications, you're really far into being able to test APIs. Yeah, there's a couple things you need to know that are different. But honestly, if not, go read the OWASP testing guide. That's how I got started years ago. But if you know how to test APIs, you're really far ahead into testing. If you know how to test web apps, you're far ahead into testing APIs, because basically an API is a web app without a UI. There's special knowledge and tools needed that are definitely for API testing. I'll give you more on that in a bit. And there are definitely gaps in API security controls. If you have a solid API security shop, you probably don't have what you need for APIs. And it might be time to sort of do a sanity check on what you have in place in terms of controls, etc. I created this web page of API security tools because I kept finding a bunch of them and I wanted to put them in something sensible. You can find this on the community pages on the OWASP website. I'm happy to take PRs. There's been several that people have added, or you can hit me up on Slack and I will add them. And I do categorize them into those 3 types of tools if they're posture, runtime, or testing. And I have open source versus commercial, etc. So I hope this is useful to you. And if you have some additions, just let me know. And then very, very quickly, here is the places where the API, the 3 different tools on the top 10 10s, where they're weak. And where I have weak, they really support, but they don't directly impact, versus where they have a direct impact. And then in some cases, like a mass assignment or testing for logging and monitoring, etc., they may not have any impact. Or like the up arrow arm on improper assets management for posture. That's what posture does. So I apologize for the fire hose, and I have 6 minutes for questions.
Thank you very much, Matt. It was extremely enlightening, and I think it covered so many topics, and it has to sink in first. However, there is one specific question regarding the test tool recommendation. Is there anything that you can recommend?
Ooh, wow, that's a hard one to answer because it's all over the place. So here's the trade-off you need to think about. I'll tell you how to think about it, and then you can solve it for yourself. It's money or time, right? If you have money, likely a good commercial tool is going to save you time, but you have to have budget to make that happen, right? Versus open source work very well, generally speaking. Like Zap does a decent job of testing APIs. If you have a good Swagger spec and you feed it to Zap, it can do a good job of testing APIs, and it's $0. So that may be a great place to start. I tend to like to try a couple of open source free tools because it's kind of I trade off a little bit of time to understand if they're useful. And then depending on what kind of coverage you get, you may or may not then decide it's time to pony up or ask for budget to get a commercial tool. And because the commercial tools will do a lot of hand holding for you. They'll make nice output. They'll be updated regularly. You know, there's just, I mean, it's a time or money question, unfortunately. And Zap, though, is not a bad way to start. And if nothing else, use a free tool to understand, sort of get a smell test for your APIs. If the free tool is really noisy, maybe you just need to solve a lot of problems before you pay a vendor to fix issues. Or maybe that may scare management enough to give you lots of budget and you go buy a tool. So it kind of depends.
The usual security answer. It depends.
Yeah, like a lawyer. I know. Sorry, bad me.
You said in the beginning there are nothing yet formalized in sense of API hardening, but what is the best practices that you would tell us to watch for and go for in the priority?
Yeah, that's a great one. So there's several things you can do that I think are just kind of fundamental and almost design time decisions, which are, I think, better to fix than bugs, obviously. So I like well, for lack of a better term, the automagical data binding from, say, a DB table to a post or a response to an API request, right? You have these to JSON, like I mentioned earlier, functions that will just take a data model internally, however that data is represented in your app, and turn it into a JSON and then send it over the wire. Now, from a developer productivity perspective, those are awesome. Those rock. From a I don't want to leak data perspective, those are horrific. And on the flip side, if you have a read in data and magically turn it into table data, I have mass assignment problems. So although it is more work, which is always an interesting conundrum to sell to management, having specific data objects for the API that are different than your internal objects, I think is really important, because it makes it explicit, right? Instead of it magically happens, because it could be that developer one used it to JSON, right? And then there are 3 jobs later where some new person who inherited legacy code is told to add a field, and they add a field, and suddenly that's exposed. And it's really kind of, well, I mean, I guess maybe it's somebody's fault, but that could very accidentally and non-maliciously happen. But if you have the explicit objects, I have to add that very, very, explicitly to make that not happen. The other big area is authentication or authorization, excuse me, and actually the whole token management can be really interesting for APIs. This is where I think having an API gateway makes a lot of sense, because if you have 12 APIs behind an API gateway, and API gateways handling the, like, say, JWTs for you, you don't have 12 different potentially different implementations of JWT handling. You have one, and it's at the API gateway. So this is one of those kind of rare cases that if you do it right, you can get more security and have less work for the developers. Now, granted, if I can bypass that API gateway, things get really interesting. So it's not without its cost, but that's another great area to get some benefits.
Unfortunately, we have to wrap up here. Thank you very much, Matt, for your talk and the input you gave.